Welcome back to Talking Science with Yoks, episode 5, take 2. Hi, Nadiya.
Hi, Akshita.
How's your day going at work?
It's going unexpected because it's Sunday, but I hope to be going back home soon, so it should be fine.
So what do you do at HudsonAlpha?
Yeah, so I work at HudsonAlpha Clinical Services Lab, CSL, and CSL performs several genetic tests for patients, and we also do genetic screening for general population perform. And I, as a clinical translational scientist, I need to understand the science behind the tests, and I also need to know how the tests are performed. So I need to understand the method and the techniques that are done to actually implement the test. So, and I need to know that information and to have the skills to be able to help to troubleshoot if anything goes not as planned. And if we want to change something in the test or adjust to our needs, for example, we are introducing a new instrument, or we are changing a source of material that is an input from our test, so we need to tweak the test. So my role is to also help in such situations. And the most maybe comprehensive task as a translational scientist for me is when we need to, we as a lab want to introduce a completely new test and perform as a clinical genetic test for our client. And also, I get to analyze the data that this test produce before the results are reported back to our clients or to physicians who ordered this test on behalf of patients.
So you get to see a full case, but also you work on tiny pieces of the part of it?
Yes, exactly. So I get to know the machinery of how it is done, and also why it is done this way, to be able to, work on the test before it is implemented. But I also have a privilege to actually look at the results, not for all the tests we perform, but at part of the tests I get to analyze results before our lab director reviews the results and signs. Ultimately, it's a lab director who signs the report, and then it goes back to our clients or physicians.
Can you give an example of a case that you've worked on recently?
Well, for example, I can describe the part that is before the results are generated and the report is generated. So, for example, we are now finishing the validation of a new method for whole genome sequencing. So this new method is known to produce more precise and detailed information about human genome than the method that we previously used for whole genome sequencing. And so we hope that after we finish the validation and implement that as a clinical test, we will be able to diagnose more patients with genetic disorders and solve more genetic mysteries, because this test is more, as I said, more precise and more detailed.
I'm sure you already work with a lot of high-tech machines, but as in the process that you are of finding more tests to be more accurate, is there a machine that you would like to see that would make it more accurate?
Yes, you're right. So we are currently rely on quite a few really cool robots and machines that help us to be more precise and to eliminate human error. What I would love to see in the lab is a sort of maybe assembly line that could help to automate several processes. So I think that's maybe implementation of some other robots that can talk to each other. It's essentially, yeah, it's a robots. I mean, like an instruments that can be programmed to perform a specific task, right? But the assembly line that you have, for example, for assembling a automobile, right? The same idea would be the same idea would be implemented in the clinical lab, and where you receive a sample and you get these instruments that are programmed and talk to each other to push a specimen toward the final spit out the results, and we get to analyze. And of course, we always need to be monitoring and watching, but that's, I think, would hugely help us to, again, eliminate human error and just to relieve some stress from different maybe activities in the lab.
How about data analysis? You do a lot of data analysis too, right? How much more improvement do you think we have to see in bioinformatics?
Yes, that's also a good observation, that the amount of data that we are, especially in human genetics and just in even genetics field, the amount of data that we are working is incomprehensible for just a human mind. So to be able to maybe to evaluate the data on the big scale, and to assess from a different points of view, I think the development in artificial intelligence field would be welcomed in our field really much. And we do see a lot of cool tools and bioinformatic tools and pipelines that help us to look at the data and see the statistics, so that we know what is normal and what is not. And to actually, so these tools and pipelines also help us to process the data in a, first of all, in a rigorous and the same way, right? But also of course, speeds the time that needs to be spent for analysis also decreases. But there are still a lot of maybe nuances that can be solved better with some bioinformatic tools rather than human mind. But of course, that every bioinformatic tool or every pipeline has a human mind behind it. So we do have a couple of bioinformaticians who work in the lab, but we also, and we really rely on their work, and that is, I think, became an really important part of human genetics in clinical lab in particular.
How did you get into this field?
That's quite an interesting question, and because my path maybe was not always straightforward, and maybe I don't know, sometimes challenging in a good way. But I actually really love where it brought me to. So I always liked life sciences, and as an undergrad, I studied ecology. After 4 years of university, studying at university in Kiev, in Ukraine, I entered a graduate program and got master's in environmental sciences. And after that, I worked in environmental NGO. So it's slightly different for what I'm doing right now. But then my husband and I moved to Japan, and it's in Japan where after some time, I got an opportunity to work at human molecular genetics lab, which was quite a new experience for me. It was still in biology and in a life science area, but I got to learn a lot new about human genetics and a lot of new techniques. And I turned to like pipetting and liking to. I didn't know about myself, but I liked working at the bench. So I worked as a researcher in human genetics lab. My husband and I then moved to a different university, and I continued my research. And by that time, I was a co-author of several papers with my colleagues, and maybe had one paper as a first author. But I was just doing research there, and he suggested, why don't you write up a couple of more papers and wrap it all into the thesis and defend it and get a PhD. That was quite a new idea for me and unexpected, maybe, because I wasn't sure how is it going to influence my career, or did I need it? But I followed his advice, and after several years, I defended my thesis and got a PhD in human genetics. But by that time, my husband and then 3.5 years old son moved to US, where I was started looking for a job, for a position. And when I was looking at different jobs that a geneticist can do, I came across genetics labs, clinical labs, and the description was really appealing to me. I wasn't able to get any job back then in a clinical lab, simply because I didn't have an experience, working experience in the United States, and got a position at Human Genetics Lab, again, also as a postdoc. After working some time at that laboratory, my PI announced that he was moving his lab to Huntsville, Alabama, and everybody who wants to follow him is welcome to follow him. So after some considerations, my husband and I decided that we would move to Huntsville, which we did, and I started working in HudsonAlpha, first as a postdoctoral fellow, a postdoc, working on research projects. But I also, on my research project, but I also was participated in a much larger project that utilized whole genome sequencing for solving mysteries of undiagnosed disease, individuals with undiagnosed diseases. And so that again reminded me about my desire to be part of a clinical genetic lab. And so again, just looking around and talking to different people in the field, I applied for a position at genomic medicine training program. It's a program for MDs or PhDs who would like to enter the field of genomic medicine. So it's a joint program between UAB and HudsonAlpha. I became a trainee there, and I finished this training program, 2 years training program. After which I applied for a position at Clinical Services Lab where I am currently working. And fortunately enough, again, HudsonAlpha, by the time HudsonAlpha started maybe developing a growing, already existing clinical lab into a much stronger and more independent entity. And so we had a new lab director, and they were looking for new people. So it was great, maybe coincidence, but also an opportunity. And so I ended up being a scientist in CSL, and really happy about that.
So what you're saying, it's really hard to get into human genetics.
Probably. Well, as I said, my path is quite not really straightforward, but along the way, again, I learned a lot of new techniques, or studied maybe different aspects, and got to know a lot of different people. Many of them were great scientists. But again, back to your comment, it's probably not that hard to get into human genetics, especially if you start from studying that. But at the same time, of course, it's a growing field, and there are a lot of different areas that you can work in. Again, as a bioinformatician, for example, so going from the computer science area, or starting as a technician in the lab, as long as you or trying to disentangle the human genes or human genome information that is buried in the human genome.
Can you work with just a master's, or do you have to have a PhD?
So I would say for example, for the position that I work right now, I would say you would need a PhD. Yes, I think simply because you are expected to to work pretty independently. Of course, we work as a team, but you are expected to have maybe an experience to work on a project independently, and to also have some experience in particular in molecular biology or genetics, and preferably have some also already acquired skills or experience at the bench. So yes, I would say for a position similar to mine, a PhD would be required. But to just generalize and to maybe if we look at the clinical lab and who works there, there maybe multiple. There are multiple opportunities for different levels, and there is also some room to grow.
How much of your work is hands-on versus working on the computer?
Yeah, I would say it may depend on the stage that a particular project is at right now. So, for example, what I've described at the beginning, that we are now validating a method So sometimes it would be 80 or 90% for me to work at the bench. But there are times when it is almost everything behind the screen, or analyzing data, or writing up some summaries or reports. So maybe overall, or if we do an average of all the different stages and across the several months, I would say it's probably 30-40% at the bench, and 70-60% as a dry lab. We call it wet lab and dry lab.
So you've lived in 3 different countries. Is there one particular thing that has influenced you the most living in one of these countries?
Interesting, but also difficult to answer the question, maybe. So, and it's hard to extract something really specific. I think just an experience experience of living in different countries overall, unquestionably was had an influence on me in general, right? And an influence of different cultures, and being able to meet people from different backgrounds. Just that that fact alone, of course, had some footprint, right? But I think I was fascinated, and I still think that's incredibly valuable that I was able to experience. So fascinating the way Japanese society works, and I actually admire their ability to work as a group. I think that is something that I was, I maybe still, already had maybe in myself, being also brought up in a country like Ukraine, but looking at or experiencing altruistic behavior in Japanese society helped me probably to install in myself that this is something important for a human being, as a member of society, again, a member of community. And it also probably layered on on top of my background as as ecologist and environmental scientist, because such topics like, for example, climate change or any other environmental issues are really near and dear to me. And so I think they are really important, and I think they are real. For example, climate change, and that is something that we cannot tackle without acting as a community. And so, again, going back to Japanese society, I think that they are presenting a good example of how some personal maybe issues can be you put advantage a greater good, maybe, or community goals, society goals, over your personal inconveniences or your personal struggles, maybe, or I'm not saying everybody needs to, again, to neglect themselves, but I think that is something that could be really valuable to bring up as a part of education, maybe, or as a part of something that is seen as important for each human being.
Thank you so much, Nadiya, for taking time out on a Sunday while you're still in the lab.
Thank you. Again, I'm just stopped by to do just a couple of things, but it's nothing that will keep me here for a long time.